Hello everybody and welcome back to Maths Miss Buick. In this video we're focusing on differentiating exponential functions and we've got 3 examples today. So let's look at example 1. We've got y is equal to e to the power of x squared. So first of all let's write our notation down. So we have, this implies dy dx when we differentiate. And when you differentiate an exponential, you differentiate its power and you put it down to the front. So if you differentiate x squared, you get 2x because you bring your 2 in front. So there's your 2x and you rewrite exactly the function as it is again. So there we go, that's the answer. So we differentiate the power, put that to the front and then rewrite your actual function again. So on to the next one. So we have dy dx to represent we're differentiating. So if we differentiate our power here, which is sine x goes to cos x, and we put that differential in front. So now we have got cos x, and rewrite everything as it is, e to sine x, and we're done. On to number 3. We have y is equal to e to the power of 2x plus 1 all over e to the x. Well, you can see here that straight away we've got a fraction, and fractions must be differentiated using the quotient rule. So let's label u and v. Okay, so let's work out our 4 things for our quotient rule. Okay, so we have u, we have v, we have du dx, and we will have a dv dx. Okay, so our u will be what we have labelled e to the 2x plus 1. Our v will be e to the x. Or du dx, well, let's differentiate this. So differentiate the power, and if you differentiate the power you get 2, and you put the 2 to the front and you rewrite your function. And now let's get dv dx. So if we differentiate x we get 1, put the 1 to the front, but we never really write that, we just say e to the x. So if you differentiate e to the x, you get e to the x, and that's what's in the log tables. Okay, so now let's write out what the quotient rule looks like. So we have v du dx minus u dv dx all over v squared. Okay, so let's, on a new board, fill in our quotient rule. Okay, so we have v. So our v is our x, or e to the x. And we're multiplying that by du dx, which is 2e to the 2x plus 1, minus u. Our u is e to the 2x plus 1. And we are multiplying that by dv dx, which is e to the x. And this is all over v squared. So we have e to the x to b squared. Okay, so let's work out this. Well, let's think about the rules of indices here. So we are multiplying e to the power of x into 2e to the 2x plus 1. So if you're multiplying powers, it means you have to add your powers. So we have 2e. Well, if we add x and 2x, we get 3x plus 1. That's that part dealt with. Now we've got our negative sign, so bring it with us. And going over here, we're multiplying our 2 exponentials with our powers, so we add the powers. So 2x and x is 3x plus 1. All over e to the x to be squared. But don't be fooled. So let's have a look at this over here in rough work. So it's e to the x, and it's been multiplied by another e to the x, because that's what x squared means. It means itself by itself. So these are being multiplied. So that means we have to add our powers. So we have to add the x and another x together. So we have 2x. A common mistake here is to say x squared, but it's not. It's e to the power of 2x. Okay. Now we're taking away. So we're taking away a negative e to the 3x plus 1 from this. Well, there's 2 of them here, and we're taking away one of them. So I'm saying, as I say one of them, I mean e to the 3x plus 1. So if we're taking away this one from 2 of them, of the same thing, we're just left with e to the 3x plus 1. all over e to the 2x. Now we're nearly done. So next of all, we're dividing our powers. So when we divide our powers, it means we take them away. So we keep our e and we take away 2x from 3x to give us x. And of course, we're left with a plus 1 as well. So there we have it. Our answer is e to the power of x plus 1.